Hello friends, this video on circles part 3 is brought to you by examfear.com. No more fear from exam. Let's move to angle subtended by a chord at a point. So we know what is chord. We'll see the angle subtended by the chord at a given point. First, let's understand what do you mean by angle subtended by any line. So if you take this example, any triangle, let this be PQR, and if I say this is angle 1, I can say that angle 1 is actually subtended by line segment. Which line segment? Is it PQ, QR or PR? It is PQ. And it is subtended at point R. So we see angle 1 or angle PRQ, both are same, right? That is subtended by this line PQ at point R. Okay, that is the concept of angle subtended by any line. Angle subtended by PQ at a point R. Please spend some time to understand this concept. When you say angle subtended by a line, so in this case, when I say this is an example where I can say that angle 1 is subtended by line PQ at point R. So let's do the same thing in circle. So there is a circle here, and let's assume that there is a chord AB, and let's see the angle subtended by AB. So we can subtend an angle, this chord can subtend an angle at the center of the circle. Correct? This chord can also subtend an angle in a major arc. This is a major arc. And this chord can also subtend an angle here in the minor arc. Okay? So if you see, this is a minor arc. So if AB is the point, AB and B are 2 points in the circle, AB is the chord, this AB is a major arc, and let me put a C here. So I have ACB is a major arc, and AB is a minor arc. I have 2 arcs. So this chord AB is nothing but a line segment, right? Will subtend an angle at center. Let the center be O. This will be angle 1, this will be angle 2, and this will be angle 3. Right? So this line segment AB subtends an angle 1 at center. This line segment AB or the chord AB subtends an angle 2 at point in the major arc. The same line segment AB or the chord AB subtend an angle 3 at a point in the minor arc. Okay? So let me write here. Just understand the statement. Angle 1 is what? It is nothing but angle subtended by chord AB at center O. Angle 2 is what? Angle subtended by chord AB at a point in major arc. Angle 3 is what? Angle subtended by again chord AB at a point in minor arc. Right? So if you see, all these 3, angle 1, angle 2, angle 3 are actually the angle subtended by the chord AB. But angle 1 is the angle subtended at the center, angle 2 is the angle subtended at a point in the major arc, angle 3 is the angle subtended at a point in the minor arc. When you talk about the angle subtended, you talk about the angle subtended by a line and angle subtended at a point. For example, angle subtended by a line PQ at a point R. Angle subtended by the line AB at a point O, angle subtended by the line AB at a point in the major arc, angle subtended by a chord AB at a point in the minor arc. That is the concept. Okay. So let's try to figure out the relationship between the length of the chord and the angle subtended at its center. Okay. So we have seen that this is the chord and this is the angle subtended. So let's see the relationship. If the length is more, is it subtending a higher angle or less angle? So let's see if there is a relationship between the length of this AB, length of the AB, and the angle 1. Angle 1 we are talking about. Okay. So let's see what we can do. So let's draw 3 different chords of equal length. All these 3 chords are equal length. Okay. And then find the angle subtended by these chords at the center. Let's draw the angle subtended by these chords at the center. So you have to do this activity on the piece of paper, draw a circle, and then draw these 3 chords. Let me just write a name A, B, C, D, E, F are the 3 chords. And then if O is the center of the circle, just draw, join these points A, O, let me put the point O, A, O, B, O, C, O, D, O, E, O, and F, O. And then measure these angles. So let this be angle 1, this be angle 2, and angle 3. So what you will observe, that angle 1 is equal to angle 2 is equal to. Right? So what you have constructed? So you have constructed 3 chords where AB is equal to CD is equal to EF. So you have constructed 3 chords in the circle, and then you have constructed these 3 angles also. Then you observe that all these 3 angles are equal. Thus we see that this is actually a theorem where we say that the equal chord subtends equal angles at the center. Okay, so this is our observation: equal chords subtend equal angle at the center. This is actually a theorem: equal chords of a circle subtend equal angle at the center. So let's try to prove it. So we have drawn a circle, we have 2 chords, and these 2 chords, let me name it A, B, and C, D are the 2 chords where AB is equal to CD. This is given, right? And let this be angle 1, this be angle 2. So we have to prove it. Angle 1 is equal to angle 2. That is what we have to prove. We can actually prove it easily. So we can take these 2 triangles, and using congruency techniques which we have learned, we can prove that these 2 triangles are congruent. So let's try and take triangle AOB and triangle COD. Why? Because see, these lengths are already equal. We know AO, BO, CO, DO all are equal because all are radius. Right? So let's compare these 2 triangles. Let me first draw here for you. A, AB, and then I can say here, I can say anything actually. I can say AOB, COB. Yeah. So if you see, AO will be equal to OC, AOC both are radius. OB will be equal to OD, both are again radius. And AB is equal to CD given. So by SSS, you can see that these 2 triangles are congruent. So let me write here. AO is equal to CO, BO is equal to DO, right? They are radius. And AB is equal to CD, that is given. Therefore, triangle AOB is congruent to triangle COD by side rule. And if the triangles are congruent, angle 1 will be equal to angle 2. It is corresponding pair of congruent triangles. Okay. Now let's check if the converse is also true. Let's see if the converse is also true. And actually it is yes. The converse is also true. And the converse theorem is if the angles subtended by the chords of the circle at the ends of the circles are equal, then the chords are also equal. So here it's other way around. It is given that angle 1 is equal to angle 2. And let me again put the values here A, B, C, D. So we have to prove that AB is equal to C. Same thing we can do using again congruency of triangles. So let's take these two triangles, AB, AOB, and I can say COD. Okay, so if you see, these two sides are equal, OB is equal to OD, it's also equal, and these angles are given equal, right? Now using SAS, both are congruent. So we will write in triangle AOB and COD. OA is equal to OC, OB is equal to OD, both are radius, and angle AOB is equal to angle COD, that is given AOB, COD. Therefore, triangle AOB is congruent to triangle COD. If they are congruent, the corresponding side AB and CD will be equal. And this is congruent by side angle side. SS. It is easy. Right? So now you have learned two theorems. One is if equal chords subtend equal angle at the center. The second one is the converse, that is the angle subtended by the chords of the circle at the center equal, then the chords will also be equal in length. Okay. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.